because as we get through section 5.3 and some of the ones that go along further, having an idea of how to break down a radical or understanding something that's a perfect square, even when you're factoring, is something that can come in really, really handy. So we just decided on these to put them up to 20 up on the top of your sheet, just so you've got a good reference, but also maybe as you start to see them more, they kind of start to slowly work into memory to make life a little bit simpler. So we've talked before about how radicals, how we can break them down. We got to have a perfect square. We got to have one that's not. We kind of work this out. What we're going to start doing is using that to actually start to solve more of these. So for instance, up at the top, 1 through 8, most of this, not all of it, most of it, yeah, should be something that is not real new. So for instance, when I'm looking at these, remember, one of the two numbers that you use as a factor to be able to break down has to come from this list up here. Not the ones in red, but the ones in black that we can break down into the numbers in red. So I need two numbers that multiply to 24, but one of them has to be from the list of black numbers above. Oh yeah, I was going to say he's a little ahead of me, but yes. So like for instance, 4 times 6 gets me 24, but as we've mentioned before when we were breaking down radicals, square root of 4 is perfect. It gets out of radical jail with a new identity. 6, however, is not in my list. It is still acting irrationally. So it has to stay underneath. And no, that cannot be switched. I cannot write 6 square root of 2. That's something completely different. So the one that breaks down perfect each time, so in this case, number 2, it'll be 4 one more time. 4 times 3 is 12. But again, that big kicker with these is, the big thing that can get some of you is, only the perfect one gets out. Now sometimes this can take a little bit of a twist. 9, okay? Here, some of you may look at 3 and say, okay, but I did 4 and 12. And we've said before, in these, the biggest key is you need to get the biggest perfect square out. Otherwise, you may have to do it twice. So in this case, 4 and 12, even though 4 is a perfect square, is not going to do me what I need because 16 is better. Square root of 16 is 4. Square root of 3. And you're like, okay, I'm starting to see how this works. It's not too bad. What if we start going twists in, like 6? Now, 6 shouldn't be something that's too bad. Yeah. Okay. Yeah. That has 7 and... Oh, okay. Yeah, back on number 6, where it said 2/3, because again, I may not even have to do a separation with these. Sometimes I may get perfect squares right off the bat and just go straight to them. Square root of 4 is 2. Square root of 9 is 3. Okay, I'm done. But then the weird things start to come in. One rule with square roots is whenever you have a final answer, you can't have a square root in the denominator. Okay? So, what we have to do here, we have to, I don't want to say call it play a trick, but we're going to do something this way. What I'm going to do is I'm going to break this up. And what we're going to do is what's called rationalizing the denominator. It sounds like a real complex thing, but it's not really. Basically, here's what you do. Whatever radical you see in the denominator, we're going to multiply the numerator and the denominator by that same radical. Like, okay, now why would I want to do this square root of 3? Well, let's multiply across and see what happens. 2 times 3, okay, that's the square root of 6. What's 3 times 3? 9. Okay, these become the square root of 9. What's the square root of 9? 3. I don't have a square root in the denominator anymore. So what I think you'll find, I want to do number 8 before I mention it, because I think some of you will start to notice a pattern when we do this. What am I going to be multiplying the numerator and denominator by in number 8? Okay, square root of 11. So you're like, okay, so square root of 66 over 11. What you basically are doing here, for what's happening in reality, is when I do both by 11 or by 3, I'm basically just wiping out the square root in the denominator. Notice this became 3, this became 11. And I'm just multiplying this number times whatever's up top. Now sometimes that may break down, and we'll see that as we get a little further into these. But the general idea is the same. If I have a square root in the denominator, multiply by that square root, and we should be able to get rid of it then. Okay? So when it comes time then to start solving the equations, x squared normally means there's going to be 2 answers, and there will be most of the time. So we've talked before about how we had a square root, we'd square both sides. Well, now it's just the opposite. What's the opposite of squaring something? Square rooting it. But here's the kicker. It's not just 4, yes. Because if you go to your calculator and you just hit the square root of 16, it's going to tell you 4. But it doesn't know, oh, it's x squared we're trying to find. Because 4 squared, true, is 16. But negative 4 squared, negative times negative is positive, and that's also becomes the same thing. So that's something that you've got to keep in mind. Before I can do the square root, though, I always have to have my squared alone. So that 2's got to go. So how do I get that 2 out of there? Yeah, we're going to divide by 2, then square root it. Okay, rarely, except if you just have a regular x squared, will square rooting be the first part. So what are my 2 answers going to be? Plus and minus 5. The square root of 25 is 5. I sure can. Okay, what about 11? Okay, minus 1. Okay, whenever we're doing one of these, whatever is furthest away from my x squared that needs to get out of there has got to get out of there first. So I'm going to have to minus the 1 first. Then divide. Okay, now, I heard the D word get mentioned. Okay, we're avoiding the D word here. They're like, oh, crap. Because the whole idea behind understanding how to work with a radical is actually leaving them in that form. So, when I do finally get to x squared, and I do finally do the square root, they're like, oh, here's why he had us doing 7 and 8 above. We need to rationalize the denominator. So what am I going to be multiplying the numerator and denominator by? Square root of 2. Now, whether you do that up above or you do it down here, okay, either way is fine. And some of you might be able to start finding some shortcuts for this type. So what we're doing here is, again, 7 times 2, it's okay if I have a radical up in the numerator. 2 times 2 is 4. That gets me the square root of 14 over 2. I do not want the decimal version of this. Okay? It's starting to get us some background as we keep going further to make this a little bit easier. So 12 is kind of similar. What do I need to do first? Okay, add the 5. Then multiply by 3. And finally, square root it. So what do I end up with? Okay. Anybody have anything to add back on number 11 before we move down? Okay, we got to have plus minus on these. Unless, of course, you have something that simplifies all the way down, and then we can literally split it and get 2 solutions, which will be coming. But for now, that's what we have to do. Okay? So, as we go a little further, they start to expand a little bit, but the concept is still the same. 13. What may we want to do first? Multiply by 3. So if I multiply both sides by 3, still got my quantity here. Now what? Can't yet because I've got parentheses there. Those are locked in together. So like, ooh, this is going to change up from what Harty said before. Now I do have to deal with the squared next, because it's the next thing that I have to do to start working at getting at my x. So here's where the fun kind of starts. So I get rid of those. So that gets rid of my parentheses here. But the square root of 21, I remember, well, it's plus minus, because whenever we do the square root, get rid of that squared, we're going to have plus minus. So when I go to minus the 5 now, this gets a little crazier, because our first inclination is to try and take it away from the 21, but I can't. This is not under a radical. This is. So when it says radical goes in the back of the answer, here's what that means. I'm going to subtract the 5 over, so that'd be negative. And then I put the plus minus in my square root of 21 after it. Now, if the 21 were something that broke down, I'd break it down. And so you're saying, well, could I put plus minus square root of 21 minus 5? Yes, but it's one of those things where mathematically, this is how answers get written. It's sort of like when you say, I've got an answer 3/9. Well, do I have to put it to 1/3? Yes, because again, we're trying to get it into its simple form. So we just kind of try to work these out, but the whole thing is continue to keep working at getting towards x by itself, but start with what's furthest away. So like in 14, where would we start? Okay, how do I get it out of there? Divide it. I'm multiplying it times that quantity. I don't want to distribute it. I'm going to go ahead and I'm going to divide that through. And then similar to what we did back in 13, the next thing I've got to get rid of is the parentheses, the squared part. So that takes care of that. I've got to remember plus minus on my square root side. And then my last step is to just get the one part that's still attached to x. I'm minusing 1. I'm going to plus the 1 over. I can't break down the radical anymore, so I just leave it. Now, I mentioned before, there will be some cases where the radical gets broken down. So we are going to take a look at 15, even though it looks a lot like 13 did. Similar to what we did on 13, here we multiplied by 3 to get rid of the fraction. Now I'm going to multiply by 2. Similarly, like we've done in the last two problems, when I see the parentheses and there's nothing else around, the square root comes next. But here's where life changes. I can simplify the square root this time. I know it's still plus minus. But here, I can break down the square root of 28 into 7 times 4 and get 2 times the square root of 7. Now, I can wait and do this at the very end. And if you want to, that's fine. But sometimes you tend to forget if you don't do it right away. And then my last step, again, is to minus the 8 over. And be very cautious on one last thing. This 2 square root of 7, okay, these are locked together. I cannot try to combine this and call it like negative 6 or something like that, or try to do negative 8 plus 2 and negative 8 minus 2. These are locked together. If it was just 2, I could break that up. I could do negative 8 plus 2 and negative 8 minus 2 and get 2 answers. But with the radical there, I have to leave it alone. Okay? No options with that. It doesn't change. I can't do anything else with it. Any other questions on the front? I'm going to stay away from the radicals at the bottom for right now. I think we've kind of eaten that up above here a little bit. Okay. Let me flip over. And let's take a peek at a few more of these up at the top. Just this work on getting x squared by itself, okay? I don't see parentheses this time. So more than likely, my squared root part is going to be at the very end. Where might a good place be to start on number 20? Okay, yeah, whatever's the furthest away from our x squared that's still on this side is the first thing I need to be looking at. So I'm going to add the 1 over. Then what? Multiply both sides by 25. And now that I've got that squared term there, now I can square root. But remember, two important things to remember here. Yep, we know it's plus minus, but I also need to check to see if it breaks down. Slide this down a little. We're looking for the biggest one up top. It'll go into 300, which would be 100. Square root of 100 is 10. Square root of 3 is still irrational. So if I can break down the radical, I need to. In this case, I was at the very end, and I went ahead and I did that. But sometimes it may come sooner than that. So let's say you get yourself, let's say, into a situation, maybe like this. You're like, okay, that's no different than what we've been doing. I'm going to divide by the 4 first. I'm like, that's a good call. And then, well, I can't add the 1 yet because the parentheses and the squared is here. So I'm going to square root this next. And then we're going to hit one more new situation. What's the square root of 25? 5. So this is plus and minus 5. I'm not just going to write the answer and say, ooh, I just add 1. I'm not just going to write the answer as this because there is no radical. There's no reason I can't simplify this. So what I'm really doing here is I'm saying, okay, I have 1 plus 5 as an answer, and I have 1 minus 5 as one of my answers. And I can literally get to the two solutions. So if your radical breaks down clean, if it ends up being a perfect square that you're taking, make sure that you go ahead and take that one extra step and actually simplify it. Okay, go ahead and finish it off. And again, that can be different from problem to problem. So I mean, here you're like, okay, there's nothing out front, not dividing it by anything. There's no other number like an adding or subtracting off to the side. So if I just do the square root right away, what's the square root of 81? 9. Now this one I'm going to break up a little bit earlier because I'm like, okay, that's clean, but I got all this stuff over here to work with. Instead of going and going and going and making this more complex, here's my idea. I'd say, okay, I'm going to split this up. I have 2x minus 5 equals positive 9. And I have 2x minus 5 equals negative 9. Once that radical is gone, okay, once the parentheses or the radical is no longer there, make it into something that's a little easier to work with. Add my 5 over. And even though on this I could do the plus 5 and then divide by 2 and then simplify it, I tend to find that that causes more trouble than help for a lot of people. But again, I can get to two regular solutions. I believe the last twist then that I can find to throw at you, the last one, would be on 23. This is sort of like what Amy mentioned back at the start of class with, ooh, got x squared in different places and stuff, how the heck am I going to deal with this? Everything needs to get to one side, just like it was before. So in this case, you have some options. If I want to get my x squareds together, so let's say I try to bring these over here. So I have 2x squared I'm just going to kind of take this one real slow. At this point, since I'm trying to solve for x squared, okay, I don't have to get this into a form where I'm trying to factor it necessarily. In this one, I could say, okay, I want to get this solved for, so I'm going to add the 5 over. And some of you, I think, were trying to do this before when we were factoring even. You're trying to solve it, works. Divide by 2, so I want the x squared alone. And then do my square root. Now, could I get it right if I factored it and got all the terms to one side? Absolutely. That's why we give you all these tools to work with. Then you can get to a point where you can make the decision on which tool you're going to use. So I could have had 2x squared minus 8 and then factored it, and that would have worked too, but whichever one tends to work easiest is the best way to go. And finally, deep breath. A couple of story problems that we end up finding up in the end aren't real hard to deal with. It's just reading through all the information that we've got. All right, so we've got an object dropped. If any of you happened to see anything yesterday with the space dive, I think is what they call it, the guy who jumped out of a capsule from 127,000 feet up in the air and was going about 600 miles per hour on the way down to Earth, he ended up fine. That was interesting. I actually watched that. But no, he had a spacesuit on. But it was interesting watching how fast he was spinning and how fast he was going. He was going upwards of 700 miles an hour for a while. Yeah. I don't know. I've never understood why somebody would feel the need to do something like that. But it was kind of interesting to watch. I was more hoping he wasn't going to blow up from the little force that was being involved there. But that would have been a mess. So, what we're going to do here is, we're talking about this object being dropped. Its speed continually increases. That's very true. And therefore, its height above the ground decreases at a faster and faster rate. Okay, now let's understand what the parts are here. The height, h, this guy, in feet of the object t seconds after it drops can be modeled by the function, where h sub o is the object's initial height, where we're starting. This model assumes the force of air resistance on the object is negligible. This model works only on Earth, so it's not what have worked with the guy when he was up above our normal stratosphere. So, let's move up just a little, because we want to be able to see all this. So we have a stunt man working on the set of a movie. It's going to fall out of a window 100 feet above the ground. For the stunt man's safety, an air cushion 26 feet wide by 30 feet long by 9 feet high is positioned on the ground below the window. Okay, first things first. We're going to use this equation. So let's see what we know. Let's see. H sub O is the object's initial height. Do we know where we're starting from? 100 feet. Okay. So we know we're going to have a plus 100 in here. We're trying to find how many seconds, which is going to be t. So the t squared we don't know right now. But the h is going to be the place that he is going to end up landing here. So here's the question. How far will he fall before he hits the cushion? Is the cushion at 0? Are we going to hit the ground? I hope not. That would be messy. The height would be at 9 feet, because that's how high this cushion is placed. So that's going to be my h. Okay? Most of the time on these, we're looking at going to the ground, so it would just be T0 here, but in this case, it's going to be 9. So I go ahead and start solving this for t squared. What would I need to do first? Subtract the 100. And they're like, are you going to make us do this in a radical? Since we don't speak in radical, you don't go up to somebody and say, hi, I just fell 91 halves feet in this many seconds. That's just kind of silly. So in this case, when we do go ahead and divide by the negative 16th, the radical, since it's an actual life situation here, is okay, because we don't speak of seconds and radicals. That'd be kind of silly. 91 divided by 16 gets me this decimal. And again, in this case, that's okay. And I do my square root. We're going to have to think about this for a second. So this guy's going to hit that cushion in a little over 2 seconds. Do I get to keep the plus and the minus? Can't have negative seconds. That doesn't make any sense. So I just want the positive 2.38 seconds. I can figure out how far I can take this ball. And that's kind of important if you're doing a movie or thing and you've got a gust of wind coming and you're trying to shoot a scene. You need to kind of know how long everything's going to take. So then, a movie camera operating at a speed of 254 frames per second records the fall. How many frames of film show the stuntman falling? No fancy formula here. What do I have to do with the 254? That's right. Take the 254, multiply it by the 2.38. And since he's on a partial frame here, we'll round up at about 605 frames of film are going to show this guy in his little mini freefall. But again, these are apps that people actually have to use and have to understand force and gravity with. Falling object model, which basically is the same as the one up above. T is in seconds, H is measured in feet. Find the time required to find. Slow down, Harty. For an object that is dropped from a height of s equals 100 and s equals 200 feet, does an object that is dropped from twice as high take twice as long to reach the ground? Okay, here's my equation. So again, I can't say, I don't know. It's going to hit the ground. So what's my H going to be? 0. 0, negative 16t squared, and they give me the s. Okay, the s is going to be 100 feet. So again, I want to get t squared by itself. And whether I add it to the other side or subtract the 100 doesn't matter. I'll get the same answer at the end. You're like, I'm going to get a decimal again. Yes, we are. 100 divided by 16, 6 1/4. And then square root it. My time ends up being 2.5 seconds for it to drop 100 feet. So the question now is it going to take twice as long? Is it going to take 5 seconds here? Probably not, but let's double check, just to be sure. So you're like, okay, so this basically sets up the exact same way, except now I'm taking the square root of 200 divided by 16 instead. Yes. Because we don't just divide by 2 when we're talking about twice as fast, we're talking about squaring or square rooting something. So it does not take anywhere near twice as long. A little bit longer, a second. But again, when we start free falling, that speed starts to increase, and this shows that. If it would have been 5, we'd have been falling at the same speed. That would have been kind of weird. So here's how this works coming up through Wednesday now. Up at the top of your sheet is the actual assignment that goes along with this. Tomorrow when you come in, there will be a quiz preview that we will talk about and do over answers, questions, and things to dust. And we'll get you ready for the quiz on Wednesday. I'll put the checklist back up for this homework check, but there's not a whole lot of assignments in whole. Basically, it's 5-1, 5-2, and what we were doing on Thursday last week. Yep, I will put it up tomorrow. Just with what we've been doing. Again, it's going to be short. I think there's only 4 things this time. And that is